Assalamualaikum and hi everyone. Right now, we are going to present our first group assignment for computer network course. Next, meet the group members. I am Nurul Farhana, binti Sharuddin, 2210285 as the first presenter. For the second presenter is Nur Batrisyia, binti Mohd Shuhaili, 2210286. We are both from 1TSC. Now, we are going to discuss part A.
First question is how to prepare the data format. There are 6 steps to prepare the data format. First and foremost is data collection. Relevant data is gathered from operational systems, data warehouses, data lakes and other data sources. Second step is data discovery and profiling. The next step is to explore the collected data to better understand what it contains and what needs to be done to prepare it for the intended uses. Next, the third step is data cleansing. The identified data errors and issues are corrected to create complete and accurate data sets. Then, the fourth step is data structuring. At this point, the data needs to be modeled and organized to meet the analytics requirements. Next step, which is fifth step, data transformation and enrichment. In addition to being structured, the data typically must be transformed into a unified and usable format. The last step is data validation and publishing. In this last step, automated routines are run against the data to validate its consistency, completeness and accuracy. Next question is how data being divided. Data is divided into packets because it makes the network more efficient. It allows the network to balance the load across various pieces of equipment on a millisecond by millisecond basis. In addition, if there is a problem with one piece of equipment in the network while a message is being sent, packets can be routed around the problem, ensuring the delivery of the entire message. The third will be the explanation about header for each layer. At each layer, a packet has 2 parts, the header and the body. The header contains protocol information relevant to that layer, while the body contains the data for that layer, which often consists of a whole packet from the next layer in the stack. Each layer treats the information it gets from the layer above it as data and applies its own header to this data. At each layer, the packet contains all of the information passed from the higher level and nothing is lost. This process of preserving the data while attaching a new header is known as encapsulation. Then, how is header being added to each data? The transport layer encapsulates the data by adding the appropriate header to each piece. These data pieces are now called as data segments. Fifth question is please explain about segment. Segmentation divides a computer network into smaller parts. The purpose is to improve network performance and security. The sixth will be the explanation about frame. Frames are small parts of a message in the network. It helps to identify data and determine the way it should be decoded and interpreted. Next is about the explanation of sequence. The sequence impedance network is defined as a balanced equivalent network for the balanced power system under an imaging working condition so that only single sequence component of voltage and current is present in the system. The eighth question, what is address route? The address tells the computers in the internet, hosts and routers where something is topologically. Routing is an activity that transmits information from a source address to a destination address through an interconnected network. Routing occurs at the network layer 3, in the Open Systems Interconnection (OSI) reference model. The devices that provide routing and forwarding functions are called routers. The ninth will be the explanation of MAC address. A media access control MAC Then, what is IP address? An IP address is a unique address such as 192.0.2.1 that identifies a device on the internet or a local network. IP stands for Internet Protocol, which is the set of rules governing the format of data sent via the internet or local network. Lastly, what is packet forwarding? Packet forwarding is the basic method for sharing information across system on a network. Packets are transferred between a source interface and a destination interface, usually on two different systems. Forwarding is the general term for moving data from input to output.
Next, we move on to error control related. Error control is the technique of detecting and correcting blocks of data during communication and happens in the data link layer, which is second layer. While in transmission, data might become corrupted. Errors must be discovered and resolved in order to maintain dependable communication. Error correction and transmission of prepared packets are used in a number of error control systems. Acknowledgement, timeouts, and negative acknowledgements are all typical error control methods. There are two sorts of faults that can occur in a network, which are single bit errors and burst errors. Single bit error affects only one bit of data, whereas a burst error affects two or more bits. The two types of error control methods used in communications are forward error control and feedback error control. Additional redundant information is sent together with the data in forward error control. This assists the receiver in detecting and locating the fault in the data being received. In backward or feedback error control, a little amount of additional information is sent with each character to assist the detection of faults. The receiver in this technique does not do any error correction. If errors are discovered in the received data, the entire data is resent. Because of the amount of redundant data that is transferred, forward error control is less typically used. After that, we move to handshake protocol involved. Before normal communication occurs, the handshake step establishes automated parameters for communication between devices. The computing handshake, similar to how a human handshake sets the tone for the subsequent conversation, provides devices with standards for how data should be shared between them. Transfer rate, coding, alphabet, parity, and interrupt process and other regulations are examples of these rules. TLS or Transport Layer Security is one approach to protect communications according to Cloudflare and is the foundation for how HTTPS works. The handshake procedure begins a connection between a computer and a device such as modem, printer, or server by instructing the devices on how to communicate with one another. The noises created when the two dial-up modems connect to each other are an ideal illustration. It's the handshaking operation that makes the squealing noise. Before printing, a handshake can be used between a computer and printer to instruct the printer on how to receive and reproduce the data it received from the computer. Handshake is frequently used to check the quality or speed of a connection, as well as every authorization that may be necessary to finish the connection between devices, in addition to sharing protocol information. Forming a connection between your computer and a distant server frequently involves these objectives. Next is TCP/IP. Transmission Control Protocol, which is TCP, is a communication standard that allows application programs and computing devices to communicate over a network. Its purpose is to send packets across the internet and ensure that data and messages are delivered successfully through networks. TCP is a protocol that organizes data for transmission between a server and a client. It ensures the data being transmitted over a network is secure. TCP creates a connection between a source and its destination before transmitting data, ensuring that it remains active until communication begins. It then subdivides huge amount of data into smaller packets while maintaining the data integrity throughout. Meanwhile, the Internet Protocol, which is IP, is a means for transmitting data via the internet from one device to another. Every device has an IP address that identifies it and allows it to communicate and exchange data with other internet-connected devices. IP is in charge of defining how programs and devices communicate with one another via packets of data. It is the main communications protocol that specifies the formats and rules for transferring data and messages between computers on a single network or across many internet-connected networks. It does this through the Internet Protocol Suite, which is TCP/IP, a group of communications protocol that are split into 4 abstraction layers, which are the application layer, transport, internet layer, and link layer. Next, we move on to UDP. UDP is User Datagram Protocol. It is a communications protocol that is largely used on the internet to build low latency and low tolerance connections between applications. UDP speeds up transfers by allowing data to be transferred before the receiving party has agreed. As a result, UDP is beneficial in time-sensitive communications, including voice over IP, VoIP, domain name system DNS lookup, and video or audio playback. UDP is an alternative to the TCP. UDP and TCP both run on top of IP and are referred to as UDP/IP or TCP/IP respectively. There are, however, significant differences between the two. Access-to-process communication is possible with UDP, while host-to-host communication is possible with TCP. TCP is dependable transport channel that sends individual packets. UDP, on the other hand, is the best effort mode of communication that transfers packets called datagram. This means that UDP makes no guarantees that data delivery offers special features for retransmitting lost or corrupted messages. UDP provides two functions that the IP layers does not. It assigns port number to aid in differentiation of distinct user requests. It also has a checksum capability that can be used to ensure that the data arrive correctly. After that is routing. The process of determining a path across one or more networks is known as network routing. Routing principles can be applied to any network, including telephone networks and public transit. Routing selects the path from Internet Protocol IP packets to go from their origin to their destination in packet switching network like Internet. Routers, which are specialized pieces of network hardware, make these Internet routing decisions. Next, we move on to subnet. The subnet, also referred to as a subnetwork, is a network within a network. Subnets improve the efficiency of networks. Subnetting allows network data to travel a shorter distance to its destination without going through unneeded routers. The way IP addresses are built makes it very easy for internet routers to discover the proper network to route data into, as seen in the preceding example. However, in a Class A network, for example, there could be millions of linked devices, and finding the proper device could take some time. This is where subnetting comes in handy. It reduces the IP addresses to one that can be used by a variety of devices. The following is subnet address. Subnet addressing allows many networks to share the same internet address in a same contained system. The subnetwork of TCP/IP's functionality also works as single network to be divided into numerous logical networks called subnets. For example, a company can have a single internet network address that is visible to customers outside the company, but it can divide its network into departmental subnets within. In either instance, fewer network addresses are needed, and local routing capabilities are improved. A network address and a local address are the two portions of a conventional Internet Protocol address field. Subnets are created by dividing the local address portion of an internet address into a subnet number and a host number. The subnet is designed so that communications may be reliable routed via the local autonomous system. Next, we want to see how the data travel in binary. Data transferred through a wire is translated into binary code, which is a series other representing zeros. The device receiving the data will decode the current as binary code, which it will then convert back to the data's original format. The internet standards regulate the amount of data that may be processed in a certain amount of time. Furthermore, cables that the data will travel in binary. Fiber optic cables are made up of strands of glass because they are extremely long and thin, often thinner than a human hair, and are used to transmit light. These strands convey binary code as light pulses to relay data. Transponders at both ends of the cable convert data to light and lights back into data. Last one for part A is network topology. The topology of your network refers to how nodes, devices, and connections are physically or logically connected to one another. Consider your network to be a city, with the topology serving as the road map. There are numerous methods to arrange and manage a network, just as there are different ways to arrange and maintain a city. For example, ensuring that the avenues and streets can enable movement between the busiest areas of town. Each has benefits and drawbacks, and depending on your company's needs, different arrangements might provide you with a higher level of connectivity and security. Physical and logical topologies are the two methods of network topology. The actual links and linkage between nodes and the network, the wires, cable, and so on, are referred to as physical network topology. Logical network topology is more theoretical and strategic, referring to the conceptual knowledge of how and why the network is set up, the way it is, as well as how data flows across it. Hi, we meet again. Now we are reaching to part 2. In this part, we will go to send a message from Node A that is located at University Farhana National, Malaysia, with this IP address, to Node B, located at University Malaysia Sabah, with this IP address. This message has 233 characters and it contains 1864 bits in total. I want to show how this message goes through the 7 layers of Open System Interconnect OSI model.
Hello, my name is Nur Batrisyia. I love UPM. You will be graduating in 2024 with CGA 3.8. I will work hard to make sure that I can achieve something that could give a positive impact on my life while enrolling a degree study in UPM.
The first thing first is the 7th layer, which is the application layer. In this layer, the message is called data, and the device that operates in this layer is the layer 7 firewall. This layer function is to serve the application, protocols, and services that interface with the end user. Basically, it is what we see on the screen of our computer. Next, in the 6th layer, which is presentation layer, the data is formatted, converted, encrypted, decrypted, compressed, decompressed, and sent or presented to the user. The file types are translated at this layer. In this case, the data is an SMS file. After that is the 5th layer, which is the session layer. The functions of this layer are establishing and keeping alive communications for session duration, keeping communications secure, synchronizing dialogue between two nodes, determining if communications ended or where to restart transmission, terminating communications, setting term of communication, and identifying session participants. Furthermore, the data then goes to the transport layer, which is the 4th layer of the OSI model. In this layer, data is going through a segmentation process where the data breaks into multiple smaller units called segments and add headers. I divided the data into 32 bits per segment, and it turned out to have 58.25 segments now. It will increase the data transmission efficiency of certain network types. The device of this layer is the layer 4 firewall. Other functions of this layer are it facilitates end-to-end communications between multiple applications simultaneously, establishing the connection before data issue. Then, the third layer is the network layer. The network layer receives the segments and converts them into packets and adds further information, which is logical addressing. The devices for this layer are the router, multi-layer switch, and wireless router. These layer functions are: first, providing host addressing, which is IP, which the system is assigning unique identification numbers to network devices. Second, choose the best path to the destination network, which is routing. The factors used to determine path routing are the delivery priority, network congestion, quality of service, and cost of alternative routes. The third is to switch packets out of the correct interface. Lastly, maintain the quality of service, which is QoS. This layer also is connectionless end-to-end networking. The following is the data link layer. It's the second layer in the OSI model. In this layer, the payload data and the data link layer together combine to form a frame. A packet from the network layer backs up the data part of a frame. A frame, in other words, contains a packet. The devices used in this layer are switch, bridge, network interface card, which is NIC, and wireless access points. There are two data link layer sublayers, which are logical link control, which is LLC, and media access control, MAC. LLC provides services to the upper layers, while MAC manages access to the physical medium and appends the physical address of the destination computer